Machine learning is a fascinating field in which computers are taught to perform tasks without being explicitly programmed to do so. Instead of directly coding instructions for every specific task, machine learning involves feeding data into algorithms to help computers learn and improve their performance over time. This is the Cloud's Guru, and join me as we unravel the beauty of machine learning. The term machine learning was first coined in 1959 by Arthur Samuel while he was working at IBM. Samuel was developing artificial intelligence or AI systems capable of playing checkers, and his pioneering work laid the groundwork for what we now recognize as machine learning. Fast forward several decades, and machine learning has become a fundamental component of many products and services we interact with daily. These systems typically perform two primary functions: classification and prediction. Classification involves categorizing data into predefined classes. For instance, in self-driving cars, a classification algorithm might determine whether an object on the road is another vehicle or a pedestrian. In healthcare, classification algorithms can be used to identify whether a patient has a particular disease based on medical data. On the other hand, prediction involves forecasting future events or outcomes. Examples include predicting stock market trends or recommending the next video to watch on YouTube. The journey of developing a machine learning model begins with acquiring and cleaning data. Since machine learning models rely heavily on data, the quality of the data is crucial. The principle garbage in, garbage out highlights that if the data fed into the model is flawed or irrelevant, the resulting predictions will also be unreliable. Data scientists address this by performing a process known as feature engineering, which involves transforming raw data into a format that better represents the underlying problem. Once the data is prepared, it is divided into two sets: the training set and the testing set. The training set is used to train the model, meaning the algorithm learns from this data to build a predictive model. After training, the model is tested using the testing set to evaluate its accuracy and performance. This step is crucial to ensure that the model performs well on new, unseen data. Choosing the right algorithm is a critical step in machine learning. There are various algorithms to choose from, ranging from simple statistical models like linear regression to more complex ones like convolutional neural networks, CNNs. Every machine learning algorithm aims to minimize an error function. For classification tasks, such as distinguishing between a cat and a dog, the error function might be accuracy. For regression tasks, like predicting the price of bread, metrics like mean absolute error are used. Python is the most popular programming language among data scientists due to its extensive libraries and frameworks that simplify machine learning tasks. However, R and Julia are also commonly used. These tools help make the process of building and deploying machine learning models more accessible and efficient. In conclusion, machine learning is a powerful tool that allows computers to learn from data and make predictions or decisions. The end result is a model that can be used in real-world applications, from embedded devices to cloud-based services. Thanks for watching, and don't forget to like, subscribe, and hit the notification bell for more insights into cloud computing. See you in the next one.